Hey, good evening, everyone. I'm Yash Mittal, your chair here at ACM at ASU, and I couldn't be more excited to kick off tonight's event. For those who might be new to our community, ACM at ASU is the fastest growing computing club on campus. Our core mission is pretty simple. We bridge the gap between your incredible academic journey and the dynamic world of tech industry. We're here to bring your insight, connections, and opportunities that turn classroom knowledge into real world impact. And tonight we have an absolute star who embodies that very journey, Punja Ranjan. Pooja, thank you so much for taking out the time to share your invaluable experience with us. It's not every day we get to host someone who is not only a fellow Sun Devil alum cheering for ASU with us, but also a leader shaping the future of technology at Oracle Cloud. Pooja earned her master's in computer science right here at ASU and has since soared to become an engineering manager leading the data science notebooks team at Oracle Cloud. Think about that for a second. Uh, from these very halls to leading teams of software and machine learning engineers designing AI ML platforms and driving cross organizational initiatives at a global tech giant. That's seriously impressive. Her journey is exactly the kind of inspiration that fuels our community, whether you're passionate about coding, cloud platforms, or applied machine learning. Tonight, Pooja will walk us through some incredible relevant topics designed to give us a clear roadmap from academia to industry leadership. We'll cover everything from how your foundational coursework connects to real industry practices, to the ins and outs of the software development lifecycle, the magic behind DevOps, and even the nitty-gritties of data warehousing. Basically, if you want to understand how software gets built, shipped, and managed at scale, you're in for a treat. And her talk. After her talk, we'll have a dedicated Q&A session. So start thinking of your questions now, and you can drop them in the chat or save them for later when we open the floor. Without further ado, please join me in giving a massive virtual welcome to the inspiring leader and proud Sun Devil, Pooja Ranjan, everyone.
Hey, hi everyone. Thanks, Yash, for the massive introduction. Uh, it just feels so good to be here. Hi everyone. Feels like I'm back home. So yeah, let me get started. Let me present my screen and then we can get started about talking. Uh, Share screen. Oh, yeah, you have to enable it, Yash. I've sent a request. Yeah. So yeah, till then, hi everyone. I'm Pooja Ranjan. I live in the San Francisco Bay Area, and I am an engineering manager at Oracle Cloud. I help manage teams in related to AI and data science. I have been in this space for about 5 years now. Prior to this, I have been working at different companies like Citrix. I've worked with like SaaS offerings of companies. And prior to all of that, I was in this very cool place, which is, oh yeah, I can share now. Let me just share my presentation and then that'll make it fun to talk. Okay. Yeah. Can you guys see my screen?
Yes, we can.
Okay. Yes. So, yeah, before I talk about the topic, right, I'll tell you why I chose this topic today. But before that, let me just tell you a little bit about myself. I was very tempted to throw in this picture of myself. No points for guessing where I am. This is because climbing the A mountain was one of my most favorite hikes ever. So, so yeah, that's me. In probably January 2013, and this is how Tempe looked like a decade ago. I know it has changed quite a bit, and a lot of new construction has come up, and but yeah, the cooler evenings of especially like the fall season after the massive heat wave. Yeah, I would love going up a mountain and contemplating about my life and my career choices and whatnot. So, but yeah, that one for another conversation. Uh, so yeah, I graduated with my master's in CS. Before that, I completed my bachelor's in Hyderabad in India in computer science, and then I moved for my master's here. I got my master's degree from ASU, and in May 2014, I graduated, and like I've been working for 11 years now. Um, I decided to actually talk to you guys about DevOps for cloud architectures. I mean, if you haven't heard all these terms a lot, please don't worry. Um, Although every word here is like a full-fledged conversation in itself, the goal of this is that I want to tell you that everything that you learn fundamentally in your academic career at ASU, those are pretty relevant topics for the industry. I want to tell you a little bit about how do those things tie into the industry, and then a little bit about uh, what is what cannot really be covered in textbooks. I mean, you can read about it theoretically, but when you step out in the industry, the first thing that will bedazzle you is the scale of things, scalability, the amount of servers, the amount of storage, the amount of transactions per second, per millisecond that happen, redundancy, scalability. These things will blow you away. So, a little bit about that. But the focus of this talk, of this conversation, is to tell you that everybody who thinks that a college degree is a waste of time, or AI, the popular one right now in the market is AI is going to take away all the jobs. No, it's not going to do all of that. We all need to do structured learning. We all need to understand our fundamentals of computer science because it's not just about writing a few lines of Python code. um, we need to understand a lot of fundamentals in a lot of areas because there are a lot of moving parts in full-fledgedly building a system from scratch and then shipping it, and then add to it the complexity of maintaining it, and then delivering it to real customers who are giving your company like millions and millions of dollars of revenue. So how does all this happen? How does our coursework actually tie into the industry? And some things that maybe are not covered in our coursework, but just a brief understanding of the entire industry, so you know where you fit in. So that's why I have this. I've chosen this topic. I call it DevOps. I'll talk about this in the later slides. So yeah, without further ado, let's dive in a little bit. So, yeah, I want to just start with talking about like fundamental coursework. I want to tie it down to our software development life cycle. So, I know that a lot of you might have already studied software design in your curriculum. And software design usually talks about how SDLC works and what are the different phases of software development, and right from the inception of an idea to how do we keep building, and then we keep incrementally building it, how do we design it, how do we actually implement things, and then how do we move towards like testing things, how do we rock solidly test things, how do we deploy things in production on our live production environments and servers. And then, yeah, once you've deployed it, your job doesn't end. Most of the times in our curriculums, we understand that, oh, build, ship, deploy, but good. That's the bit. I think point number 6 is something that we do not extensively study in our curriculum, but that the maintenance overhead of shipping and building something is massive. And it might not sound glamorous, but 50% of your time in your IT jobs, you are going to be maintaining things. And maintenance also teaches you a lot of important lessons. It teaches you more about efficiency, like, oh, if only this code had been, 2 milliseconds more efficient, we could have had supported maybe 10,000 more create or update API calls. And that could have shifted the revenue by $100,000 a month. I'm making these numbers up, but this is something that usually happens. So planning, analysis, design, implementation, testing, and maintenance. That's the standard software development life cycle. And coming back to our coursework, so algorithms. I have just listed out some of the courses that I had taken a decade ago. So forgive me if I'm a little outdated. Although, yeah, Yash and you guys have actually helped me update my knowledge base a little bit. And I actually got to understand that there is now CI/CD components that are being taught to you guys as a part of your foundational coursework, which is great. It did not exist 11 years ago. Yeah. We these found these courses by themselves are very solid and they are very, very needed. Let me emphasize that part first. Be it your algorithms knowledge. Your algorithms knowledge is going to come into play first and foremost in your interviews. Once you're interviewing for a software role, there cannot be an offer until you have been grilled on your coding concepts. I hope a few of you are very familiar with it. People who have interned or have been or have worked a little bit know that the algorithms and the coding part of it is non-optional. So your understanding of trees, linked lists, dictionaries, um, all these search data structures, stacks, queues, you name it, and all because these fundamental data structures are used a lot in organizational coding. So your understanding of these concepts is important. Operating systems, I have put this here because I feel concurrency handling, right? So the crux of operating systems is your Linux kernels and all of that. But the part that and Linux kernels are very critical, and in a cloud environment, you need them when you're setting up your hardware and your data centers and all of that. In your day-to-day life, you are going to use a lot of concurrency and thread management and thread locking and semaphores, and you have to implement dining philosophers problem and all of that, so that your load balancers can manage the amount of requests and load that comes on. So for a simple example, we could say Oracle is a cloud provider. So what is a cloud provider? A cloud provider is basically a company that can set up huge data centers for you. And they are going to handle all the hardware, the maintenance, the security aspects, the clearance aspects, the geographical location related aspects. All of that data center work will be handled by the company, and you can come in with your feature or your requirement, and you just worry about and you just tell the company like, hey, I want to scale this for 1 million users per second. So the company will help you estimate, okay, in that case you can rent out so many racks of servers, CPUs, GPUs, graphic cards or whatever, and then so much block volume, and that should do it for you. So a cloud is basically just you're talking like, okay, you are using someone else's data center to run your load. So in this setup too, your operating system's understanding of like all the parallel concurrency, thread processing, all of this come into play when you're doing all of this. A simple example is Zoom. So we're all on Zoom right now, right? Zoom has I think the scalability number for this is when they have the webinars, they can scale, you can join, have up to 3 to 400 attendees attending the Zoom session at the same time, you know? So, uh, and especially during COVID, what happened? So a fun fact, just a fun fact that Zoom is hosted on Oracle Cloud. So what happened during COVID, I'm just digressing a little bit, but I just want to keep this a little interesting so you guys don't doze off. So Zoom is hosted on Oracle Cloud, and when they signed with us, right, they said, okay, we're going to expand in so many regions. Please give us the infrastructure we need. And it was 2019, and right before the onset of COVID. And what happened then was Oracle said, okay, cool. Yeah, you just name the number of data centers you need and we're going to spin it up for you. And what you can focus on is building your brand and building your features, and the load and the scaling and all of that, and then your requirements, the services availability, all of that is totally on us. Don't worry about it. We're going to take care of that for you. Just give us a number. And Zoom was like, okay, fine, we expect to grow at this rate. So this number is a good number of data centers for us in these regions. And we had a contract with them. And then it was like, okay, cool. And then come March of 2019, everything started shutting down, right? So everything started shutting down. Everything went on Zoom. So the predictions that they had just went for a toss because their load tripled, quadrupled. It was much more than what any one of us could have imagined, which was great for Oracle because we were making money, right? We were making money. We were billing people. We were billing Zoom for using our hardware, and we were happy. But we had a tiny glitch there because even Oracle had to shut down like expanding data centers. So a data center setup requires you to rent land, move all your hardware in, do all the setup, have electricity backup, have hardware technicians on spot. So all of this was also halted because of the stay at home orders that most countries had in place. So we had this very interesting problem where, okay, uh, we cannot expand any more data centers. We have what we have, but the load is going up like crazy. So what do we do now? We have to optimize. We cannot say, no, we have signed a contract with Zoom and like, no, just bring on your load. We will scale dynamically for you. What are we going to do now? So in that case, operating systems became all the concepts of like multi-threaded usage and all of that became very, very relevant because we had to find every possible way to save CPU and GPU cycles and also block volume and storage. We had to optimize the cloud. We had to optimize our cloud to give the max amount of throughput with the least number of CPU cycles or GPU cycles, and but still keep meeting the scaling demands of the company. You know, so, so in that sense, all of the semaphores, locking of threads, all of these concepts had to come into play. We had to implement them in our load balancers, in our kernel level request handling, and all of that. Um, so yeah, those concepts were very relevant and are still very relevant at this point. Again, so algorithms, operating systems, software development, I'm sure all of you do some or the other form of this all the time. Um, be it writing a Python program, software development, you could say it's a set of like, hey, given some amount of input, and then you have to do some processing, you have to write your algorithm and then process it and produce an output. This is a standard thing that most of you are very well aware of. Also, software design, I think you guys have taken courses and understand what software design primarily is, but I'll just show you how it works at the industry level. And then, yeah, and I know a lot of you have also taken software quality assurance related courses, maybe, or plan to take one. I would really recommend you take one of these because I feel quality is something that gets really, really the lowest priority, but it has the potential to blow up and it has the potential to cause a lot of problems. And it can cost companies millions and millions of dollars in revenue. And I'll come to this bit in a bit. But yeah, let's move ahead and we'll talk about these phases and how does, again, I'll try to keep coming back to how your coursework is relevant in this entire thread. So let's move on. Yeah, so a little bit more about, so now, yeah, you have studied SDLC, most of you. If you haven't, this is the basic structure of how things work. This is the textbook part of it. Now let's talk about like once you move this textbook to to the real to a real IT industry setup, how does this work? So I'm here what I'm talking about here is mostly like a medium tier company or a large organization. Maybe startups are a little more hacky in their approach because their goal is to ship as fast as they can. But the goal of every startup is to become a mid tier company at least. They want to build revenue, they want to collect revenue, and then um, keep they want to keep building building up to the point that they become a medium tier company and their products become more recognizable and they have more revenue and um, yeah, so the end goal always is to become a mid or big tier company at the end. So I have designed the structure based on that. So what usually happens, so before we dive into this, right now, a little bit of a tangent on how the industry works here. um so in a if you think of and the IT industry as one organization, okay, you can, in simple terms, you can think that, okay, let's assume that that is a company and it tries and it sells a specific service, for example, or like an authentication service, maybe an auth SDK or something, a very simple one. It does IAM, it does the federated login, it does any SSO login, all of these things of the company. Every authentication module that the company might ever require is now contained into an organization. It's which offers a service. Now, to offer the service, you will have an organization built. Now, what's going to happen in that organization? There'll be a director, there'll be an engineering director, or if it's a big feature, there might be a VP who will be the head of the organization, and this person will be the topmost point of contact for like the critical customers, critical internal customers. In big organizations, we do have a lot of internal customers too, like other teams who consume what we are building basically. So auth, for example, right? Like anything, you can build any fancy feature, but everything requires you to finish the auth first. So a service like authorization or authentication will have almost every internal team will be their customers, right? So most organizations will have a bunch of internal customers and then obviously a whole bunch of external customers. So there'll be a VP who will be the head of the org, and then there will be directors or senior managers, and then there will be a whole bunch of people in different roles. And you need all these people to fulfill their roles so that you can finally ship a good product to the company, to the customer. Now, what kind of roles can these be? A whole bunch of people. The first category, or the entry level category is product managers. Who's a product manager? A product manager is somebody who knows about your product, who advertises your product, who goes to every customer facing meeting and says, "Hey, we have this solution. Why don't you buy it from us?" In simple terms, somebody who has been a user of the feature for a very long time and can answer any customer related query around why the feature works the way it works, and somebody who talks to customers and tries to lure them towards the service and say that, "Hey, please come on, come join us. This is going to be this feature is going to bring so much value to your product or your customer," right? So these are product managers. Then we have program managers who are like the more process people. They are going to help us manage the end to end building and shipping of the product. So when a big request comes in, a customer wants to build their own SSO over your authorization, for example. So to build this, what do we project? How much time will this take? How many engineers will this take? Um, are we going to process, are we going to follow all the due process and make sure that nothing goes wrong? And like publishing such estimates is something that program managers do. And then we come to the more technical people who are the architects. So architects are people who have usually been with the company for at least 5 to 7 years, uh, getting promoted. Architects being the architect is like one of the most senior roles in an organization. You definitely have had a lot of experience either building similar architecture systems, or you've done a PhD in those specific architectures, maybe SaaS architectures, maybe AI, or maybe agentic AI is the latest fad at this point of time. If you have done good work in that areas, then you could move into the software development track and then eventually move up to be an architect. So the architect is a person who will basically understand a customer requirement from the product person, and then he will draw out the diagram, and that's when your concepts of software design come in, all your UML diagrams that you draw. There are several softwares that you can use to draw and conduct all of these, but yeah, this person will design, he'll draw out the Java based, the object model, the plan. How will these interfaces and classes interact with each other? What network design patterns are we supposed to follow? What software design patterns are we supposed to follow? Like builder pattern, uh, a chaos pattern. There's something called chaos pattern also, where, oh yeah, we just have to shove this quick, so let's build something really fast. So architects are the people who draw out these plans in simple terms. They draw out, or if the feature is an addition to an already existing architecture, it's relatively simple, but at the same time it is you have to make sure that you don't break anything or don't violate any SLA that we have in the already existing architecture when you add something new. So they deal with different set of problems and they finally get a design. And this happens in several iterations. It's not that they get it right the first time. Nobody gets anything right the first time. You have to keep building and iterating, and then, oh, this went wrong, and then that went wrong, and then you keep doing that again and again, and then you finally come up with a pattern that the high level team of architects agrees with, and then you're ready to, okay, let's go. Now this design has been approved. We run it by the VPs and everybody, and then you're like, okay, good to go. And then there's a team of engineering managers. So like me. So what we do is that we manage a team of software engineers who will actually be working on the building of the product, building, deploying, maintenance. What I usually do is I get these requirements, I get the design plans, and I participate in the design review and discussions with the architects. And along with that, what we do is I will be estimating, oh, I have these resources and this person's specialty is this, so if I lend two of my resources to build something like this, it might probably take this amount of time. And then I put together a project plan based on that and I estimate things based on that. The other things that I have to do is handle legal paperwork, for example. Like once we build something, we push something, we will update our public facing documentation for customers to just browse and see. So, we have to make sure that we are not using any proprietary software, for example, that we have not officially purchased a license from. So there can be several legal complications and resource related problems. So I'm here to handle and tackle all of that. It sounds like a boring job, but yeah, we could do another one full hour of discussion on how interesting use cases come up in the life of an engineering manager. But that's the brief for now. And then in my team, there are the team of the actual stars, the actual heroes who are the software engineers. We have junior engineers, we have senior engineers, depending on the years you've worked and depending on depending on the projects you've contributed in the past, you move up the ladder. So I have a team of interns, I have junior engineers, I have senior engineers, and then we have a specific team of DevOps engineers who are specifically there to maintain the product. Although DevOps is something that engineers have to keep doing, as I've said previously. But we do have a specific set of DevOps people to deploy in certain data centers that have specific restrictions. You can say that. And then we have a team of quality assurance engineers who will specifically come into play when you are almost code complete with your feature, and they will thoroughly test the product. They will test it in different environments, almost close to as a production environment as they can, and they will make sure that they submit 100% happy success report before we move to deploying things. And then there is a separate org of security engineers. Security is a different ballgame altogether, right? Given current, every organization, big or small, is very prone to security risks. All the security things that you study, denial of service, cross-site scripting, all of them are absolutely true. They happen in the industry. They cause losses of several billion dollars. They cause lawsuits. They end up in angry customers and whatnot. So security engineers are a whole different org, but they are a central kind of an org, and they are evolved with every team. So before you build and ship something, you have to get the blessing of the security team. There's a process to do that. You submit your feature, and then they run extensive tests on it. They do penetration testing, any and every kind of uh, architecture specific testing that they need to run before they green flag your product. So I hope you guys I hope this is not too much, but these are the categories of people that exist in an organization on an average. So now, how do all of us come together to start shipping things? You know, so coming back to the software development life cycle now, if you look at the requirements analysis phase now, requirements come in through customers, and product managers are the people who usually interface with them. Sometimes we also do, engineering leads also do, but it's primarily product. So the product team talks to a customer and says, "Hey, we like your product or your service, but we would like to have the ability to, like, going back to the same auth example, like, yeah, we would like to implement another layer of SSO over what you're offering us for additional security benefits because our org requires us to do that." So that's something the product manager will take down, like, okay, sure, yeah, let me go back and talk to my team and we'll get back to you. They'll have a meeting of this sort. Then they will come back. They will have a meeting with, like, the engineering leads, the engineering managers, the architects, so they can understand that, okay, is this even viable or not? And are we okay doing this or not? So that discussion happens. And after that, once we rule that, okay, no, there are no blockers, this doesn't seem to be an anti pattern, allowing somebody to do an extra layer of SSO, it's an external environment to us, for example, so we don't care, and we are not going to let them bypass our auth because they have their own auth. So that's something maybe we put as a prerequisite and say, hey, okay, you guys can do that, but we will not bypass our auth because we have our own security standards, and that's not negotiable. So the customer says, all right, cool, yeah, okay, cool, agreed. It's going to be a little bit of an annoyance, though. It's not going to be a great user experience. But then that's when the architects come in and say, okay, let's try to design it in a way that maybe the second level of authentication happens under the hood. So, you collect their SSO, and then you securely transmit it to us, and then we'll try to securely sign them in into our system, but we will do that. It may not be visible to the customer, maybe, but we will still do that, and we'll try to calculate that the latency is minimum, something like this. So that's when the so in the design phase, architects are going to sit down, they're going to draw the diagram, they're going to be like, okay, this is our system, this is the new requirement, um, this is how it's looking like. It's possible there are no blockers, we're not going to run into any other issues in terms of scaling, or having to build more things over this component doesn't seem to be a problem. Maybe we should be able to do it. All right, okay, now let's draw the diagrams. That's when you take your current architecture diagrams and then you draw. There are several categories of diagrams. You guys know that already, but the data flow diagrams and um, component interaction diagrams, and then we have to clearly mark, okay, where is the boundary of our product versus where is the outside internet, and then versus where is the demarcation of the customer's subnet starting. So we're going to keep all that in mind. We're going to draw out our designs. Again, I have written this as AB reviews and ECAR reviews. ECAR review basically is an engineering community architecture review. Um, it's not that one architect is going to draw something and say, yes, this is it. This is how we're going to do it. No, there will be a lead person who will draw it and who will standardize a design, but then it has to be subject to at least 2 to 3 rounds of architectural reviews by other architects in the entire company. This is done to eliminate anything that this person might have missed. The angle of human error always exists, right? And then getting feedback from other architects of other orgs if there's a more efficient or a simple way to do the same thing you know so these discussions happen over a period of, I would say, depending on how heavy the feature is, it might take like about 3 weeks, 4 weeks, sometimes even a couple months. But this is very critical because this phase determines what your input is going to be, what are you going to get from the customer, what are you going to process, and what are you going to give back. And this helps us like legally write down our SLAs. And SLA, I keep repeating this term SLA. Let me talk about this. SLA is a service level agreement. It's a contract, basically. You can think of it in simple terms as a contract that the company signs with you. So now in our contract, we're going to tell them, okay, this will be the input we will get from you. We will do our own processing. That's going to be a black box. We're not going to expose our company's architecture. We're going to keep all that abstracted. Again, Java concepts, abstraction. So you abstract the rest of the design. It's totally a black box for you, but this is what you will get back, and this is what you want, right? So these phases are very important to establish that initial thing. Otherwise, you can start building something, and then if the customer, and then you build more than halfway, and then you say, hey, here is an almost demo ready for you to see, and then the customer is like, oh no, that's not what I wanted. And believe me, this happens more often than not. If you do not spend good amount of time designing your software and establishing, and you can implement this at your college level at everything. If there's a professor, if there's a project that has been given to you, do you understand your inputs and outputs well? Because once you understand that, half your job is already done. As a student, I had this tendency to constantly fret about, once an assignment is given to me, my brain would immediately jump into the business logic, if you guys know what I'm saying. Like if you give me an algorithm, like, okay, you say, oh, go implement sorting, for example, my brain immediately jumps to what kind of sorting algorithm do you want to use? Merge sort, quick sort, order of n complexity, whatnot. But sure, that bit is important, but you are jumping a couple steps here, and that's not good. You need to understand what kind of input will you be getting. Are you only going to run over numbers, or are you going to run over strings? That will help you design a more efficient, that will help you choose a better programming language. Do you want to be very tight about the type, about the type of the data structure that you're passing? All these things are important, and all these things are also important in interviews, because we know you have practiced your coding and you have come prepped with it, but how well can you see the overall picture? That's important. So this, I'm mapping now. Think of that example in the industry system. In the industry, you have to get your requirements diagram right. Your designs have to be approved. They have to be high level communicated to the customer, and you write down your contracts to say, okay, this is what we're going to ship for you, this is what we're going to build, and this is what's going to happen. uh, do we end up changing some things in the middle? Yeah, it does happen. It's not a stringent system where you decide to build something and then you never change it. No. Some minor tweaks, changes will keep coming in, and sometimes when you build it, you realize that it doesn't look very efficient. Let me make this change. So things like that will happen, but you do not. That delta is supposed to be like under 20%. You decided to build something with one, two, three, four features, and then you build three, and then you realize the fourth one was not worth it or not necessary. And you and the customer mutually agreed that, okay, yeah, these three are good enough. So a little bit of shift here and there is okay, but largely your base requirements are supposed to stay till or if your requirement is too big, then you ship it in small iterations, like ship out a version 1 in 2 months, then you go back and build over it, and then you ship out a version 2 in 2 months. So you do like that, it's incremental. So yeah, so requirements analysis design. Now you have everything locked down. You understand what you're going to build. Now now it's going to come to me like, okay, now this is the project, let's get started. Then that's when senior engineers and staff engineers and principal engineers, like the most senior engineers of the organization, they are going to have a sit down with the architects, and they're going to go over like, okay, now let's use these tools. Usually you have to, whatever service you're building, you have to expose it via an API, standard stuff, via CLI, again bash, CLI bash, or you can do it via the UI. Build the UI for a customer so that it's clean, simple, and just offers like a Gmail kind of an interface for you to just log in, interact, and then log out, right? So you establish all these things are done by engineers. You study, I mean, APIs, SDKs, HTTP protocols, data transfers, all of this under your software development courses. Sometimes company have a few internal tools that they use, proprietary tools, to make certain things easy. Like for example, like Oracle uses a proprietary tool to generate SDKs once you have the spec ready. So yeah, a lot of companies have a lot of such hacky tools to get things done, and they are very reliable. And over the years, they have been maintained and they have been brought up to like industry acceptable standards. So yeah, you will encounter your fair share of proprietary tools, but the underlying concept is still what you've studied and what you know. These tools are just gonna automate some of the tedious tasks for you. They by themselves are not extremely intelligent um, to do your job end to end. So now that we have developed something, now we have all the APIs ready, we have all the implementation ready, um, we have the back end ready, we have the front end ready, we have built all these things. We kind of are ready to do a POC or a demo. Sometimes customers are very eager. They want to see if you've promised them, like, hey, we're going to give something to you in 2 months. They really want to see a demo, like, oh, how good are things going? Some customers are very chill. They're like, just what, just finish it and give it to us when you're ready. Others are like, no, 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 we are so eager to try it out. Can you show us a demo? So usually when you're dev ready, when the development phase is over, that's when you are more than happy to, okay, just hold a meeting and call a couple of those folks and then just do a demo and show them. You never expose your source code and you don't show your code base to them, but you can either record a demo, or you can just show your UI, or you can show the API, like, send commands to the CLI or whatever and show them that, okay, this is how we're using it. So sometimes you do a short demo, and then that's when we tell them like, wait, this is almost, and that's when we just confer with them like, hey, this is what we decided, this is what we've built, looks good, right? After that is when the actual productionizing effort starts. So testing is a part of the productionizing effort, and testing. So deployment and maintenance is usually something that's a little off the charts in terms of our academics. Up to testing is okay, but testing, deployment, maintenance is the entire bracket of productionizing a service. So now it's sitting on your computer. You have built this beautiful auth service. It's sitting on your computer though. Okay, sure, you have pushed the code to Git and it's sitting on some master repository of the company, fine. But at this point, it's still very local. Only you can access it, your team can see it, somebody has to do a lot of local setup to get these things running, right? So now you're in that phase. Now we got to move from this and we got to deploy it in all of your live data centers. So real customers can actually use it. And medium to large scale companies will have several regions. A region by region, I mean an actual geographical region, you know, where we have several regions in India, in Asia Pacific, in Europe, in Africa, in South America, in North America, several regions in within the US, Mexico, Canada, you name it. Like, you have to build, and you build all these hardware regions so that the latency is very less. Once you deploy to all these regions, the customers in these regions will have low latency in connecting to your service and then, using the service. So now to productionize and to now it's sitting on your computer. Now you want it deployed on all these wonderful regions and you want real customers to use it and then you want feedback from them. So what are you going to do? So before we agree, again, everything is a group effort. Most of the times, these building, right? The PR, the code reviews that you're doing, you write code, you submit it you open a PR review on your branch, on your Git branch, a code review, and then other engineers from your team. Every org has requirements, like 2 or 3 engineers have to review your code, give you feedback. You have to address the feedback, only then do you merge your code, right? So these standards have to be followed. Development, although there is a lead developer, there will always be contributing people who will review and all of that, and then all your efficient code will be merged. Now, and yeah, before your code is merged, there will be a series of tests that will run. It's called an end-to-end testing pipeline, where first thing, you as a developer will add a few unit tests just to make sure that the functionality is actually working fine. Then the quality engineers are going to do more thorough functional testing, where they will make sure that not only does the feature work by itself, it works in conjunction with the product, the whole product, and then it also does not break anything that's already working, and that's called regression testing. Any one of you who has taken any of these classes, again, I will re-emphasize, your code is only as good as the test case you missed, right? So you say a chain is only as strong as its weakest link. So security is a whole different ball game, and security related vulnerabilities will be tested by the security team, but functional issues have to be caught by your team, by you and your team. Any functional, any operational issues that will come with testing your product has to totally be handled by you. So, and that's why you do like a full set of tests. You run unit tests, you run integration tests. You make sure that, now that you've built this new build, um, is this gonna break something that, a simple thing like a version mismatch. You have a dependency that has a version 2.2.0 and then this new thing is pushing 2.2.1, but you have to now go back and test any and every version that this dependency is included in to make sure that, and sometimes it has got nothing to do with the feature by itself, but it will still be important. Yeah, sorry guys. Had a quick drop by from my kiddos. Okay, so yeah, so coming back to like testing and so yeah, now we've spoken about a little bit about testing. Like, okay, we have to do rigorous functional testing, and we have to now we are making our code, our build production ready, and we're ready to go out. Now we're gonna use CI/CD tooling that will Terraform. Like there are multiple technologies that uh, that actually pick up this build, and they're going to move it and they're going to deploy it on all these different regions, the servers of these regions, and update the versions there. And usually these updates are real time, so customers are just using the service and then they get that update pushed. Sometimes it is based on an activate deactivate basis. So if you have logged out, you'll still be on the old version, and then when you log back in again, you will be on the new version. uh, and then yeah, once you have developed and deployed everything, at that point you have to, then it goes into maintenance. Yeah, sorry, looks like an audio. Okay, yeah. So now we've spoken about maintenance. Now we come to maintenance. Now we have deployed, your wonderful software is now out in every region that you could think of. Now we're talking about maintenance. Maintaining is, you have to keep collecting. So now you deploy it to like a low latency region first, where there are fewer customers. You see how the feedback is. If everything looks okay, then you go and the next you deploy to all these big scale regions with big customers. And after that, yeah, you set up metrics alarming. So if there are, you you start alarming on different error codes. So 404, for example, is a simple one, or 500 internal server error. If a customer is running to these, please alarm and send the on-call engineer a ticket and say, okay, something's going wrong. So before the customer can complain, we try to see if we can find the issue and if we can fix it. So, and then yeah, the optional step is like, yeah, everything, every data that we are collecting, all of that goes into data warehousing, uh, stored, and then we try to look for interesting patterns in that. And that's when your data mining concepts come in. Supervised learning, unsupervised learning. If the data is very clean and very well labeled, then we can pull out interesting patterns. Like, okay, if this customer's usage is going up, we can predict, okay, in the next 6 months, they're going to need so much more from us. So how do we scale our infrastructure around that? All of that. Okay. And then unsupervised learning, that, yeah, okay, there's so much data. Can we find any interesting pattern? Can we find a way to attract more customers towards this, towards our service? So something like that. Uh, okay. Okay, yeah. So on-call team. So yeah, so there's a team of engineers that is always present, folks. So now this is where things divert again from our coursework. This is where people, you have to be in the real world setup to actually learn and understand this. But there will always be a team of engineers ready to help people. If there's a problem, if there's an issue, if your service is not starting, if you are a customer and you're not be able to do something, there will be engineers available to help you. And within an organization, you take turns to go on call, and then you answer questions, and then you help customers out that way. I know we are almost at time, and I want to give you guys some time for questions, but yeah, I'll just wrap this up in 5 more minutes, people. So yeah, issues in production, nobody can escape that. And no, and it's not something that's usually punishable at an organization level. If we can help customers out, helping customers is one part of on call. But the second important bit is, we, after all this rigorous testing and stuff, we still managed to roll out an error in production. So now a customer reported, hey, this is not working. And you realized, oh, wow, this is really not working. So what do you do in that case? The first thing you do is the on-call team jumps onto the issue and they see that what is the shortest possible way to mitigate this problem. Can we roll out a new fix? Can we roll back the previous versions? Will that fix it? You understand the impact and then you fix things that way. And after that, we focus on first fixing the problem, and then we focus on the learnings that come out of it. So 5 whys. Why did this happen? Oh, because we missed a configuration flag. Okay, why did we miss a configuration flag? Oh, because there was an error in writing one of our Terraform files. Oh, why was that an error in writing? So we go 5 levels deep to start understanding how will this really help us. And so we get to the root of it, we can fix it, and then we share this learning with the overall a big org. So we understand that, okay, yeah, cool. Now we have made this mistake, you don't repeat it. And it's a very blameless process. Please don't feel, the industry is very welcoming in that way. It's a very blameless process. The goal is to learn. And you, as an engineer, if you've made a mistake that has brought down production, uh, the company's take on this usually is that, wow, our systems are not strong enough. Any new rookie can walk in and bring our systems down. So let's not do that. Let's try to find ways to strengthen our checks, our gate checks, so that something like this does not happen again. So these kind of meetings happen. And yeah, we already spoke about SLAs, but yeah, we constantly, time to time, we talk to customers and we try to understand that, hey, are you happy with everything? Are all your create and activate workflows going through? Is there too much latency in the way you're interacting with the system? Do you have problems with that? We can talk about that. And we keep updating those things. And yes, the last bit, data warehousing and extraction. So yeah, I touched upon this briefly, but yeah, we mine for different interesting patterns and see how can we use the data that we are already getting. And then there are several regulations around this. You just can't use every customer data that you're getting. There are very strict boundaries and there are very data related federal rules that you have to follow to make sure that you're only collecting operability data to actually see if you can use that to boost your revenue. So yeah, so these are the concepts that I hope you guys, I'll wind it up now. So these are the concepts I think you guys study in your college. study and as part of your foundations. And yeah, and a little bit of here and there, and then it gets adjusted, and then you end up having this fun. Yeah, go ahead, Yash.
Wow, Pooja, that was an absolute brilliant and incredibly practical deep dive.
Yeah,
From
thanks,
connecting,
guys. Sorry, I went too much overboard, but yeah, thank you.
we were all enjoying. From connecting our foundational coursework to the real world SDLC and writing down how you handle everything from SMS to big data, you've given us a masterclass. It's clear your experience is truly comprehensive. So my mind is buzzing, and I'm sure our audience is too. Now, for the moment that everyone's been waiting for, the Q&A. This is your chance to ask Pooja anything, whether it's about her journey, her leadership insights, the tech she uses, or specific aspects of cloud engineering and machine learning at Oracle. To ask a live question, you can simply raise your hand or add a question to the chat, and then you can make a start.
Cool. Yeah, I understand, folks. I have thrown just way too much at you guys, so maybe you need time to process, and we can have another Q&A. Yeah, good.
Yeah. mm, Hello, Pooja.
Hey.
Thank you for sharing all these details. Like, thank you for joining this session and explaining all these terms. So, I have few questions today. So, I'd like to know, like, from your experience, what qualities or mindsets help engineers thrive at Oracle? Specifically, like when they are working on large scale projects like large scale cloud or DevOps systems.
Yeah, that's a great question, Sayantika. So actually, it's not just Oracle, it's any company, I would say. What you, we know that you study a lot of foundational work and you come into the industry. What you need to thrive and survive is a professional attitude, first of all. Like you attend your meetings, you're professional about things, you come in on time, people don't have to, you are a team player, you're a group player, you work with your teams well, and you do all of that. But for an individual, the most critical factor is like your ability to adapt, have an open mind, learn as you go on the job. Don't be very hung up about how, hey, I did this way in my old company and this worked for us. Be very open to ideas. We want, and you grow and the team grows with you. So at the team level, being a nice team player, being professional, these are things that everybody expects everybody to have when you come in. But personally, me and a lot of engineering managers, what we look for is that your hunger to learn and grow, and your open mind. Be adaptable, be flexible with how you work. Be open to new ideas, even if you've never tried them before.
I have few more questions. So recently, I noticed that you posted one opening regarding the SD3 role at Oracle. So I have applied for that, and I'd love to hear your perspective on what specific skills you are prioritizing for this role, and how best to prepare for the interview process at this kind of senior level. So, like for engineers aiming to transition into more senior roles, what do you recommend as ways to make an application stand out? And and in terms of preparing for interviews at that level, like SD2 or SD3 or any senior level, what kind of skills and interview rounds should we expect?
Yeah, that's a good question too. So for an SDE 2, right, an SDE 1 or a 2, I would say that the only thing when you're out of college, the only thing we expect from you is to bring solid uh, programming development concepts. Okay, so you have to be a very good coder, and then we expect you to know a little bit of CI/CD, but we're gonna handhold you. We'll give you a lot more support to onboard and to learn and to grow in that role. But when you talk about a senior role, an SDE 3 role, that is when your design principles start mattering a lot more. In your interviews we will evaluate. You also have to be a good and a strong coder, but at the same time you also have to understand design concepts a little better. So we will ask you to design a simple scalable system. We will ask you to design an end-to-end website, basically. Just build it from scratch. Show us on the paper. Go whiteboarding. Draw your UML diagrams. Draw these things and show us how will it look. So your designing abilities start scaling up because we will want you to estimate projects better. So your software design part becomes a lot more relevant in senior and then staff-related roles.
Okay. Thank you. Thank you so much, Pooja.
Sure.
I think we have a question in the chat from
Sure.
Anya.
Yeah, the industry environment is quite different from class projects, true. How was the learning curve for you? So yes, of course, Anya. So yeah, everybody's gonna have a learning curve. Sure, right? I mean, that's a given. But the thankful bit is when, and that's why companies have a very streamlined process to hire new grads now, because we know that you have a lot of bright ideas, you know the latest technologies, but also you are not very familiar with these DevOps structures, these CI/CD pipelines, and the scale of things. So the learning curve is it's a steep curve, but I would like to assure you that it's a very clean process based curve. We have mentors, like your first year of your career, for example, you will not be allowed to fly solo. You will always have a mentor guiding you, helping you, and the mentor will gradually start pulling back once they see that you are becoming very efficient in finishing and managing projects by yourself. So we will not give you, for example, we will not give the biggest customer request or the most critical customer's most critical feature will not be given to you at the very first go. We do not want to put that kind of pressure on you. So you will be given a smaller maintenance task at the beginning so you understand the systems better. And then gradually we will bring you up to the level where you are a very efficient standalone operating person, a standalone operating engineer. So this learning curve is steep, but you should not stress about it. Again, as I said, just come with an open mind because companies know that they have hired you for your potential and they also know the gaps that exist. So we will guide you. We have a very structured process to onboard and to help you become a part of the team. And then we have constant one-on-ones with managers where you can talk about your concerns and say, hey, this is not working for me or I'm struggling with this. And appropriate help will be provided to you. So yeah, the learning curve is steep, but there's a process around it, and with your potential and our efforts, it always works out.
Hi, Pooja. Thank you for your presentation. So, I was just looking through your journey. Like you transitioned from like a principal software engineer to like an engineering manager at Oracle. So, like from my perspective, it seems like those roles are quite different. Like with principal engineer, like you were involved with like design, for example, automation. While as an engineering manager, you mentioned like there are so many varied things that you have to tackle, like be like talking with the architects, legal consideration, etc. So how did you decide to really like transition from that role to the next step? And like also like what specific skills did you develop like before transitioning or like while in that role like that you are in right now?
Yeah, that's a good question, guys. So, the technical skill set doesn't change. You have to be a very good software engineer, a senior engineer in the company to understand systems, and then you need that. 50% of my role is still that. I still talk to architects and I still talk to I still look at technical blockers and all of that. The new part of it is the people management part. And for that, why did I feel I want to do it? Because I always knew that I can be a good leader because I pick up human sentiments really well. So, I feel that at some point, employees start thinking it's you versus the company. No, that's not it. You and the company are one. If you're not one, then you're not going to produce the best outcome. So I felt that I had that urge to try out people management. I didn't know if it would work for me or not. 4 years ago, when I tried to take this role, I didn't know it was an experiment, honestly. I didn't know if this would work for me. But because I had to give an interview because I was changing my role, and then the seniors and directors of the company interviewed me, and they thought that, okay, I had the potential. I was the new grad again. I was back to being the new grad in management. So an entry level person who has some background of software architectures but knows nothing about people management. So I cleared that. They saw some potential in me, and then I had to go through rigorous trainings on company policies, people management, how to handle people, what to say to people, what not to say to people. Like you cannot walk in a meeting and say you're a douchebag and you suck at your job and yeah, I hate you. You cannot just say that to somebody, right? As a manager. So you have to identify problem areas, work with especially the difficult people. There are some really good people who really don't need much management. They'll just to be fine by themselves. But there are a lot of, especially the newer folks who need a lot more help from the management side. So I had to go through rigorous, intense coursework and training. And then I was put under my mentor, my senior manager. So just like the same newbie cycle, then I was a newbie for the first 3 months. I could not make management decisions and say, okay, this is what I'm telling the team to do and this is what the team has to do. No, that's not how it's going to be. I was ramped up to one-on-ones, and so it was a 50% role change, and then I had to go through the same rigorous training information. And after that, yes, I learned at the job. Just like you guys, you will learn in a couple years. You will feel like, oh yeah, I really like this part of software. I want to build. I want to do this. Or you'll feel, nah, not for me. So for me, luckily, I thought the potential, what I expected, I would have tried to become an architect otherwise if this would not work out. But yeah, it worked really well for me. I had a team of very senior engineers, people who were my peers who became my reports, but that I was able to make that transition happen and things were seamless and I started delivering projects. So after a couple years, I could trust myself and the company could trust me to start delivering things. So yeah, I had to go through that learning curve as well. And then I was subject to trainings and I was trying it out. It worked out. So all well and good. And now I'm an experienced seasoned manager, but everybody starts the same way. You switch a role, you have to go back to being the entry level person and then you learn, you take trainings, you learn from your seniors, you learn from your mentors. For some time, you cannot make independent decisions. Then when they start trusting you to make those decisions, at that point, they will let you make them.
Awesome. Yeah, that makes a lot of sense. I also have like kind of a technical question actually. So like if you go back to your
Sure.
data warehousing slide for a
hmm
moment,
hmm
so like over there, like you mentioned like using LLMs for pattern detection, if I'm not wrong.
Yeah,
Um,
yeah.
so like could you expand on like how you exactly are using LLMs for that?
Yeah. Actually, yeah, that part is proprietary, folks. Sorry about
Okay.
that. It's a very good question. But what I would tell you is that you can just explore. You know that Chat GPT is a very, very basic open source thing now that we are using, right? And you could imagine something a little more advanced than Chat GPT that is good at picking up unsupervised patterns to
Hmm.
predict things. I know this is not a satisfactory answer, but yeah, that's a little proprietary at this point. And because Oracle, Microsoft, and Amazon are like three companies that are spearheading the whole agentic AI space and LLM space. So a lot of it is proprietary. So I'm not sure how much of that is worth discussing. But please
Sure.
feel free to read a lot of papers on these things and read up blogs and articles on what Oracle and Amazon are publishing about LLMs, and that should give you some more ideas.
For
But
sure.
yeah.
I guess could you speak to the advantages of what like that has helped you in like in your workflows or something?
It's
Could you?
too early to say, honestly. It's
Okay.
too early. And the AI, LLMs, and all, it's very experimental at this point of time. It has a lot of potential, and no denying that. It has a lot of potential, and but going beyond these frivolous automated use cases, like as I said, there's a difference between automation and AI, right? So you could automate a lot of things, write a Python script to pull up insurance information of all the employees in the database, for example. That's an automation. That's not AI. You have to go and look for specific fields and then pull out that thing. You can write a bash script for that. So far, I feel automation and AI are almost at the same par at this point, but that's what we are heavily investing in right now to make sure that AI actually gives us more value. So that's a very interesting thing, but it's a very ongoing thing right now. At this point, we don't have answers. If we have good answers, we're going to publish in the public domain for people to consume. But at this point, we don't know. We don't. It's too new. But it has a lot of potential, so we want to invest in it and we want to find out what's going to happen. But at this point, we
Sure.
don't know.
And maybe like just for the audience, I feel like if you could like guide to some resources like for reading, like you mentioned, like papers or like papers in this topic, maybe you could
Oh
guide
yeah,
us some
just
resources.
read up. So Facebook, no Meta is publishing a lot of LLMs. Just Google, go to these company specific websites and read. A lot of data scientists and their product managers write a lot of blogs on their own websites. So if you type like Oracle LLM support or something or Meta LLM support, um, you will see a few blogs from the product managers of the company, and those are really good starting points for you to understand what that company. In fact, if you're interested in applying to that company, I would really recommend that you go and read the blogs posted by those product managers of those companies. So that makes you look like a candidate who has actually prepared a lot about, oh yeah, I read this blog published by your company on this, what is your take on that? So that's a good way to do it.
Thank you. Thank you so much.
Cool, folks. So I need to call it a day. Uh, and now, but yeah, if there are other questions, I can take. You can guys can forward it to Yash, and then I can try to answer it over email. Cool.
Definitely. As we reach the end of this, it was an absolute phenomenal hour, and I want to extend our sincerest gratitude. First of all, a massive thank you to you, Pooja, for your incredible insights, practical advice, and for so generously sharing your journey, um, and your journey from ASU to a leadership role at Oracle Cloud. Your presentation was truly inspiring and incredibly relevant to our students here. Let's give her a big virtual round of applause. And to all of you, our amazing audience, our current Sun Devils, future engineers, data scientists, and leaders, thank you so much for your insightful questions, your active participation, and your incredible curiosity. You are the reason we have these events. Um, Thank you so much. And before
Thank you
you
so
go,
much,
take a
folks.
quick moment to share in the chat your learnings, your takeaways from tonight's session, what you inspired you. Thank you again, everyone, for joining us. It was an absolute pleasure to host this illuminating event into the heart of software and machine learning leadership. Thank you. Good evening.
Thank you.